Hi student, myself Dr. Dharampal Singh, Associate Professor of Department of Computer Science and Engineering, JIS College of Engineering. Your subject name is Formal Language and Automata Theory and paper code is CS403. Now the prerequisite of the subject is digital logic, computer organization and computer fundamentals. And these are the course outcome and COPU mapping is given here. And the course contents, we have the 5 module and these are the content of the module there. Now today class we are going to know that converting regular expression into the NFA. Okay. So when you go for the conversion of regular expression into the NFA there, so you have to aware about the some rules. Whatever the rules written here, this is a Thompson rule there. Okay. To get the regular expression into and we have to convert this regular expression into the NFA. So how can get the regular expression? So here I can give the little bit idea. Regular expression means the expression which is accepted by the your finite state machine, and it is just like the format of this one: a plus b star, like this, a b this. In this way, it is also like this: a b star a. So this is the regular expression meanings are there. Okay. So if the regular expression which have only the null, so I can start from initial state and make this one in the final state. So we are aware about arrow means the initial state and concentric circle means the final state. So you can go for it this way. Okay. So when only the A is there, means simple A, I can write the from 0 I can start means initial state and make this one like this. If the suppose A in this format regular expression is suppose in this form, yeah, suppose A plus B in this form. So you can write this way, means one state will be there and this will be this part. So these are the process. If regular expression like concatenation of string, you can see that. So I can write the A taking the go to the this state and then B taking go to the this state. In this way we have to write. And suppose A star is there, means this one. So how we can do it? So we can say that you can start from 0 because A star means what? Yeah, if you know that, yeah, it is like just like this, and so on. This is the infinite numbers are there. So this expression you can see, taking the 0, it also go to the final state because null is also acceptable. Now you can take the A. By taking the null, I can come here. Again, taking the A, I can come to the T2. Again, taking the null, I can go to the 3. This is also acceptable. You can see. If there are 2A, you can see. Taking the null, I can come here. Taking the A, I can come here. Again, by this null, I can go back to this one and take the second A, come here, and then go for this one. So 2A is also acceptable. Similarly, for the 3A, start from 0, come here, taking the first A, and taking the null, again go back to the 1, again taking the second A, again taking this null, go back to the 1, again taking the third null A, and then by choosing this part, you can go to the final. So this is the way we can perform the tasks when the regular expressions are given. We have to convert. Okay. Now you can see this is the one type of regular expression. I can solve the first one, and second one you can take as an assignment. Because here A star B is given there. Okay. A star B A R. Okay. How you can convert? Because here we know that A star value, we know that B or A or A B value we know that, but how we can combine these two? Okay, so don't worry. We can take this is the R1 and this whole area is the R2. Okay, so how it become? It become R1 R2 just like A or B. So we know that what is the rule for A or B? This one. So we can write. Sorry. So I can start from the state Q0. Okay, taking the R1, go to the Q2, and taking the R2, go to the Q3. And make this one is the final. And this is the same thing what we have done here. You can see. But what is the value of R1 here? A star. And value of R2 is the AB. Okay. So try to solve the first this one. How we can solve it? You can see. Okay. Now how we are going to solve it? You can see. So after this, I have to go for this part. So I can write this part in this way. Q0. Okay. And we know that here these two states will be the same, initial state and the this part, because for this one Q0 will be the initial and Q2 will be the final. So I can write the Q2. Okay. And the remaining, or I am not going to go for R2 as it is. I have kept because later on we can go for the changes and make this is the year. So between these, if you know that, see this figure, initial, final. Okay. So between these two, we have to introduce two state there and write the things in this way. So same thing we have to do. So here I can write the Q1 and then we have to write the Q. Okay. So you know that, sorry, what is the these from the starting state we have to go to the null. So I can do the same thing. Starting state, go to the, I can write the here. Now the again from 0 to 1 null is there, so I can write the null here. Epsilon, I can lambda I can also write. Again I can write null here, and we know the repeat back of A is there, so I can write A here, and then this part. You can see this back to the null. A is there, again null. Same thing we have done. You can see. Sorry. This is a arrow is this way, sorry, and this arrow is this. I'm going to erase this part. Actually, arrow will be the in this way, and this arrow will be the this. So you can see this one from the this way, and this one from this way. Okay. So here this part is over. Okay. Now here I can see that R2 is the A or B. If A or B will be there, if A or B will be present in the diagram there, then how we can solve? We can first these two will be the common and intermediate state I can introduce. Okay. The same thing is applicable here. Okay. So I'm going to delete this part. Because we have solved this one. We have solved this one. Okay, in this way we have solved. Now here I can see that Q3 will be your final state, and between this part we have to introduce the one intermediate state one. Okay, here I can write, suppose Q1 so here it will be the Q2 already we have taken here, Q3 already taken it, so you have to write this one as a 4 because state must be differ there. Okay, sorry. So here I can take the Q5, or you can take as a number there. Okay, now after that, what is the written in the diagram? I can write the A from this one and B to this one. So similarly here B, A is there, I can write B here and A here. So after this one, this whole figure, if you consider, become the conversion of your this regular expression into the NFA. Why it is NFA? We know that if you in a null move, you can go to the both the value like Q0 to Q1, or you can go to the this one. So this one is the conversion of the things by using the NFA. Okay, so if the regular expression is given in this way, we can convert it. Similarly, for this regular expression, what I have given the task, we can do the simple way. Take R equal to R1 equal to AB and R2 equal to this AB bracket star. Okay, so it becomes just like R1, R2. The diagram just becomes like this. Q0 starting with the R1, reaching to the Q2, R2 again reaching to the Q3, and Q3 will be the final. After that, try to solve this one because here one intermediate state will be introduced. So you can write that Q0 and write the intermediate state A. Suppose I have written Q4 because already Q3 taken in here, and Q2 will be the there or the B, and R3 means, if you remember, this is the your just like the A B star. If I assume this is the R, it become R star. So you can apply this process here. After that, you can apply the base process of the AB. The design will be the big. So try to solve by the yourself, and I hope that you can do it. So thank you, my dear student. And when you go for the conversion, try to remember the 4 rules of the sum. Okay, and based on that, whatever technique I mentioned, try to divide the things in small part and bring according to rule and try to solve it. So I hope that this video will be clear with you.